Hi everyone! Today, I will give you a brief introduction to in the mechanical design process, the chamfering problem. The first one is called inner circle and outer square. If the hole is inside the part, because now they are all CNC machines, CNC machining, the edges and corners can be rounded. The edges of the length, width, and height can be chamfered into squares, which is C45-degree chamfer. This is called inner circle and outer square. The second type, in the process of sheet metal processing, try to make the inside round, and the outside is also round. That is, if there are holes, and the square inside should be rounded, and the external corner is due to the bending angle. Requirements: because different sheet metal thicknesses are different, but it's impossible to fold it into a right angle. It's impossible to break the sheet metal. The outside can be designed with rounded corners. The third type is whether it's sheet metal or mechanical parts. After they are done, they need to be assembled. When chamfering all the parts, we should consider that the overall beauty after assembly, like chamfering. Which is better? The fourth one is and increase strength. During the mechanical design process, the parts need to be considered after processing. There will be corners or broken forks to prevent fracture. During the heat treatment process, high and low temperature easily cause fracture. In the process of cornering, it should be designed as a chamfer recently. A 45-degree chamfer or a rounded corner. It's better to be a round corner. Some also need to be punched with a hole. Chamfer. This is the fourth type. The fifth one is in the assembly process. A round or a square, and put it in a hole or a groove for guiding and assembling. Then we can also and holes with chamfers, so that it's convenient for the assembler during the assembly. In summary, there are 5 types in the design process. The first is the machined inner circle and outer circle. The second is the inner circle and outer circle of sheet metal. The third is to require overall beauty and neatness. The fourth one, the principle of stress relief and strength increase. And the fifth is the guiding principle. Today I brought 2 stainless steel parts made of SUS 304, a common material. This product is used in electronic products. The requirements are relatively precise, and the appearance requirements are also stricter. When processing this part, we use wire cutting to process the shape first. And then what about CNC? And then process the holes and other processes inside. After processing, we will brush it. And then finally, chamfering. The chamfer of our part is like this. We put it on the flat jaw vise. After clamping, according to the drawing requirements, we chamfered the 4 sides to a 0.5 angle. This chamfer is required by the customer. This 0.5 chamfer, it has such a requirement during assembly. After assembly, the overall control box will be more angular and transitional. This chamfer, the tool used is a chamfering knife made of tungsten steel. We set it up. Another thing is, and cutting amount. And we slowly cut it out. It's a bit time consuming, but it can meet the requirements. On the back of this part, it's a little time consuming. There is no requirement, but not too big or too small. We made it to be 0.05 5 silk chamfers. In this way, no burrs to the touch, and it doesn't look too big. Only in this way can it meet the requirements of this electronic product. You will encounter, and then we grind it all, and all require such careful processing. This part is made of SKD11 heat treatment. It's used in this automated equipment. The processing technology we use is rough machining, and then heat treatment. After all grinding is completed, Finally, we chamfer the part. The chamfering of this part is also quite particular. And the process that we use is to use a grinder. Grinding wheel 45-degree chamfer, all the peripheral edges. Grinding wheel chamfer for all external corrugations 0.2 minus 0.3. The internal chamfer is more difficult. We went to CNC and slashed it to ensure that it is also 0.2 to 0.3 for this round hole. So we're using chamfering knives. We blocked it with new paint, ensuring a radius of 0.2 to 0.5 is relatively larger. After chamfering, the part looks more beautiful. And when you touch it, it's not slippery. When workers assemble it, it's also convenient.